Basic Calculus Part 2, Rate of Change and Average Gradient. Speed equals distance over time. So if I travel 60 kilometers per hour in 1 hour, 60 kilometers per hour. 100 kilometers in 2 hours, well, 100 to 2 means 50 to 1, therefore 50 kilometers per hour. So there we are. Average speed equals distance traveled over time taken. Let's have a look at John's trip. So now, in order to find his average speed for the trip, we need to find the distance traveled by subtracting and work out how long he traveled from 7 a.m. to 11 a.m., 4 hours, and that gives us 90 kilometers per hour. Exercises. Pause, try them yourself. Now, standard equation of this graph, well, this is a straight line, therefore y equals mx plus c, but also it's going through the origin. So the y-intercept is 0, so it's straight y equals mx. Now we have y equals mx, we have to prove that f of x equals 120x. So knowing the x and y, the only unknown, the only variable we need to find is m, we can substitute. And we get m equal to 120, so therefore y equals 120x. Average speed, in each case I'm going to subtract the y's, subtract the x's, and divide. They're all off this graph, and so therefore they have to be equal because it's a straight line, and the gradient of this graph gives the rate of change, and it's a constant rate of change, and average speed is rate of change. Now this is more of the sort of example you'll be doing in calculus. So there's a formula to show distance traveled in t seconds. So to find distance traveled in the first second, well, that's just the case substituting 1. First 5 seconds, substitute 5. Average speed, divide distance by time. 11 meters per second. Now, distance traveled in the 8th second, not the first 8 seconds, the 8th second alone. Now this formula will only give you the first 8 seconds, but we can subtract the distance traveled in the first 7 seconds from the distance traveled in the first 8 seconds, and that'll give us the 8th second. This is a very useful notation to be able to put what is called the suffix in maths down below the line. Distance 8 minus distance 7. So I'll substitute the 8 minus bracket, substitute the 7. Average speed in the 8th second, well, there's the distance. And how long did it take to travel that? 1 second. Some more examples. Pause, try them. First second, substitute 1. First 3 seconds, substitute 3. Average speed, well, there is the distance in the first 3 seconds, there is the time, divide, and it's 5 meters per second. Distance traveled in the 10th second, not the first 10 seconds, the 10th second, so therefore distance 10 minus distance 9. I don't need to put those in brackets because they're at the beginning, but this definitely needs brackets because the whole amount is being subtracted. Average speed in the 10th second. Well, there's the distance traveled in the 10th second. And how long did that take? 1 second. In each of these cases, we're going to subtract. We're going to, we're going to substitute to find the distances, and then we're going to put it over the time, which is subtract. Notice the pattern here, 1.9 to 2, 1.99 to 2, 1.999 to 2, 1.9999 to 2, and 1.999999 to 2. We're getting closer and closer to the distance traveled in the second second. And I'm sure you see a pattern there. Determine what the object speed will be in the at 2 seconds, 8 meters per second. Now this is in fact the sort of thing that calculus allows us to do without all these calculations. Average gradient. Well, there's a straight line, and we don't have to talk average gradient here. The gradient is y2 minus y1 over x2 minus x1. Difference in y's over difference in x. Change in y over change in x. Now, average gradient means it could be on a curve, but it does not change for average gradient, because from there to there, it doesn't matter where you've been in the meantime. The important thing is what's the change in y over change in x from there to there. Same formula. Same thing. The same. Once again, even on the sine curve. So let's find the average gradient. This one's pretty straightforward. We're given the x and y. So we apply the formula. There we are. Oh, in this case, we're only given the x's. But we're given a pretty good tool to find the y's because there's y equals x squared plus x. So if we substitute, we have the y values. When x equals 3, y equals 6. When x equals 1, y equals 0. Now we can just apply the gradient formula. -3. Another one, same thing. Now here, you could go straight to there without doing these separate calculations. Quite acceptable to do that. That's why I put it like this to show you. But having calculated that, you could have just written 5 minus -4 there. Average gradient 3. On a graph, same thing. Substitute as well. Now notice there I've done it. I've gone straight into the formula with the substitution instead of finding the y's separately. Exercises for you to try. In this first case, we have the x and y, so we just apply the gradient formula. In B, we need to substitute to find the y's. Notice once again that useful suffix, y3, so I'm saying y when x is 3, y when x is -1. And the formula. Same thing here, we're going to substitute, we're going to substitute to find the y values. And that gives us the gradient. And same here, substitute, gradient. a summary of what we've done so far in pre-calculus, basic calculus 1 and basic calculus 2, which is a form of pre-calculus. We found limits. To find limit algebraically, first, just substitute for x, hoping you get an answer. If you turn out with a defined value, that's the limit. Remember, division by 0 is not defined. Anything other than 0 over 0 means there is no limit. That's not defined. 0 over 0 is also not defined. But it gives you a prompt to simplify, to say it's 0 over 0, indeterminate says go back a step, let's just check. So there's a 0 over 0. So I'm going to go back and simplify. I say, well, oh, hang on, that's a difference of squares, that's a quadratic trinomial, that'll factorize, so there we are. Cancel the x minus 3's. Now we can substitute our 3's. Finding a limit graphically, you're given what x is approaching, so x is approaching alpha. We want to know what y is approaching. Well, there's the approach happening. And notice, as the x is going that way, the y is going that way to there. So there is the limit of f of x as x tends to alpha. Left and right limits. Not so much in this course, more in the more advanced calculus, but just to establish that a limit does not exist if the left limit does not equal the right limit. And it is possible for a function to have no value at next value and yet for there to be a limit. If you look here, there's a hole there, so the function value does not exist at x equals k, but the limit does exist. Because there we are, can approach that point, can approach that point, they're both approaching that point. Average speed, distance over time, average gradient, change in x over change in y. Final exercises. Notice there are 3 pages. Pause, try them yourself. This is to test your understanding of the concept of limit. Time and mass of a radioactive substance. Well, yes, because there's what is called the half-life of a radioactive substance, and it might be 30 years. So every 30 years it's half of what it was. It'll never ever reach 0. But ultimately that's what it is approaching, none left, but it'll never be totally there. Time and temperature of a cup of hot tea. Yes, it'll approach room temperature. Time and the men's 100-meter world record. Certainly. I'll tell you what, that if we said, will anybody ever run 1 second for the world 100 meters, I would say no way. So there has to be a limit somewhere. Number of terms in this and the sum of the series. Like there's 1, then you add, you get 3, you add, you get 7, you add, you get 15. Those numbers are getting bigger and bigger, faster and faster. So no, it increases. There's no limit. The value of 1 over x as x approaches infinity. Well, the bigger x gets, the smaller this gets, but it's never going to get to negative. And you can't end up with 0. So, yes, the limit is 0. the position of Q and the length of PQ in the drawing on the right. So it's getting closer and closer and closer. Yes, notice there's the length of PQ, there's the length of PQ, there's the length of PQ. Ultimately, when PQ becomes the tangent to the circle, the length will be 0. Calculation of limits. Well, we can just substitute. This is a bit of donkey work, I guess. It's just a case of substituting. You'll notice that we're approaching closer and closer to 3. From the bottom, we're approaching closer and closer to 3 from the top. Left limit, right limit. And you'll see what we're going towards, hopefully. If x tends to 3, then f of x tends to 9, and the limit is 9. Now we're on limits. First thing we do is substitute and try that and see if it works. It works on the first one. It works on the next one. It works there. It won't work here. You get 0 over 0. So we factorize first, and we end up with the limit of x plus 2 as x tends to 1, and that we can do. This one, it won't work. We'll get 0 over 0, so we factorize. The x minus 3's cancel. We get x minus 4 over x plus 4. Substitute the 3, and it works. And the last one needs factorizing as well. Stone dropped from a certain height to fall to the ground. Movement represented by s equals 5t squared, where t is the time in second, and s represents the distance it has fallen in meters. Now, in each case, first, second, third, fourth, fifth, sixth. So we're going to have to do that subtraction from the second. First one, substitution. S2 minus S1. S3 minus S2, because we're not finding the distance traveled in 3 seconds, just in the third second. S4 minus S3, etc. So there we are. Substitute the first one. Second one, we have to do a substitution, and we subtraction, and we get 15, and it's in 1 second, 15 meters per second. We get 25, and it's in 1 second, therefore 25 meters per second. This implies something about the average speed per second, doesn't it? But those who are the science pops know that we have what's called terminal velocity. So this is just theoretical, just getting used to limits and average speed. Compare your answers. What do you observe? Yeah, the speed's increasing by 10 meters per second per second. Is the object accelerating? Yes, the speed is increasing. That's acceleration. At what rate? Well, every second the speed is increased by 10 meters per second. So it's 10 meters per second, which means 10 meters per second squared.